Hi everybody, this video today is going to cover section 8A, section 1. Unit 8 is divided up into part A and part B, so this is part A. We're talking about inequalities today, and honestly I think this is going to be a little bit of review for you. I'm hoping this will be an easy section for you. When we talk about inequalities, first of all we use these signs. Like this sign is the greater than sign, this sign is the less than or equal to sign, and of course this is just an equal sign. One thing about inequalities is they represent a whole bunch of answers. Like if I just ignore this question and just look at this only, x is greater than 3. That means everything bigger than 3. It could be 4, it could be 5, it could be 800, it could be 900, it could be 3.001. It's everything that's greater than 3. There's a bunch of possibilities. But it cannot be 3 itself because there is not an equal sign. Whereas with the other one, x is less than or equal to 2, let me get over to that one. X is less than or equal to 2, that means it could be negative 2. Sorry, it should be negative 2, right? Could be negative 2, could be negative 3, negative 4, negative 100, negative 8,000, negative 2.1. All of those numbers are less than 2 and less than or equal to negative 2. So all of those would be possibilities. So the less than and equal to, greater than or equal to, they all represent more than one possible number. So the question here, is 4 a solution? Okay, is a solution means if you plugged it in for x, would it work? Is 4 greater than 3? That's what that's saying. So yes, 4 is greater than 3. Sorry. Here we go. Yes, because 4 is greater than 3. So yes, that is greater than 3. Is 0 a solution to this? No. Sometimes people get confused with the negatives. So if you think about your number line, and think about where these numbers are in relation to on the number line. So like if this is 0, negative 2 is down here. Now the positives are over here, but the negatives are over here. So the question is 0 a solution to x is less than or equal to negative 2? No, because 0 is up here, negative 2 down here, and less than is all the way down here. Another handy little thing to remember is that the arrow points in the right way that you're supposed to go. So that means you're going to the left, and 0 is not to the left of negative 2. And then the last one, is 6 a solution to x equals 5? No. If it is an equal sign, there's only one possibility. It's 5 and only 5. 6 is not equal to 5. But on these other ones, there's a variety of answers. There are a bunch of answers that you could put in. If it's an equals, though, only one possible solution. Okay, let's remember about our signs, how we graph these on a number line. So we'll be graphing these on a number line. And when we do that, again, if you're not sure, let me remind you, this means less than, and this one means greater than. And this one was less than. So if it's less than or greater than, you use an open dot. That means it does not include the number. Okay, that's like up here. Greater than 3 does not include 3. It might be 3.1, but it does not include 3. And so we put an open dot there. If it is a solid dot like this, then we say less than or equal to or greater than or equal to. And that means it does include whatever number we're talking about. So that's like on this one. X is less than or equal to negative 2? Yes. Negative 2 is included in that. But so is negative 3 and negative 5 and negative 8,000. All of those are in there too. Okay, so let's practice this a little bit. We're just going to use the x, and the x basically represents everything that's shaded. So all this shaded stuff, this is our x. And then the number is here, and of course we want to say it's solid, so it's going to be an equal to. This arrow, whichever way is pointing, is going to be our clue. Let me show you. I'm going to say x is greater than or equal to negative 4. Greater than because it's pointing this way, equal to because it's solid, and negative 4 is the number we're starting at. So anything greater than or equal to negative 4 is shaded over here. Okay, let's do it again. This one is pointing this way. Again, this is our x business. So we're going to say x is less than, this time no equals because it's open. And 2 is the number we're talking about. X is less than 2. Points this way, everything lower than 2. This one, look at how it's pointing. X is less than. This time it does have an equal to because it's solid, and it's 3. That's the number we're dealing with. Last one here, x greater than, over here, but no equals, it's open, and a negative 5. We'll practice this in class. All right, now they're asking us to go the other way. Okay, we're going to follow the same basic principles I was just talking about. So we're going to go the 2, and I'm going to make a circle. I have to think about, do I close it? I fill it in or not? No, I don't, because there's no equals, so I don't fill it in. It says greater than. Greater than means this way, pointing, that same arrow is pointing the same way that that arrow is pointing. X is greater than 2. Okay, a is less than or equal to negative 6. So I go to negative 6, I make a circle. It has an equals. Since it has an equals, I have to fill in my dot. It says greater than or equal to. The arrow is pointing this way. It's all the way over here. And again, we'll do practice of this in class. Go to 3, put an open dot. I have to look. Oh, I'm supposed to close it in because it has an equals. So I close it in, fill it in. Points to the left, so I draw it to the left. And that's my R. R is less than or equal to negative 3. Everything less than or equal to negative 3. And the reason we fill it in is like, it includes this too. That's why it's solid, okay? And our last one, 5, does not include 5. So I don't actually put the dot on the 5. I just put it outside of it. And then less than means it's going to go this way. Some people think of less than and left. That's another way to do it. But the arrow points that way. Let's go to the next page. When we solve, which we will be solving inequalities, basically it's the same rules as solving an equation. You do the same exact thing as you do with equations. The only new little bit of information is if you multiply or divide by a negative number, you have to flip the inequality symbol. You have to point it the other way. So let's take a look. If I do this, I need to distribute this. It's going to give me a negative 2n. Negative times negative is a positive 18, greater than or equal to 26. All right, I'm going to solve this for n. I'm going to subtract my 18 from both sides, just like I would if it was an equals. It's just a little bit different, but it's really the same thing for most of it. When I subtract that on my calculator, I get an 8. I divide by negative 2. Now here's where our rule comes in. I just said if we divide by a negative, you have to flip it to point it the other way. I'm running out of space. Let me see if I can make some space for myself. Okay, I was able to scoot some things a little bit so I could get some space there. So when I do this, I'm dividing by negative 2. I'm going to point my sign the other way. I have to do that, divide by negative 2. That gives me a negative 4 over here. It gives me an n over here. I want to graph this. So I go to my graph. I go to negative 4, which is here. It has equals with it, so I have to fill it in. And it is left than, which means to the left or pointing the way the arrow is pointing this way. Let's try another one. I'm going to solve it like I would a regular equation. I'm going to subtract 7. And that gives me a 5x over here. I'm going to divide by 5. That gives me 6 less than or equal to x. Now, I didn't have to flip my sign because I didn't multiply or divide by a negative number. But it's kind of backwards. Like every single one that I've done, I've actually written the other way. So there's a couple ways you can do this. I really think what you need to do is, and maybe we need to add another line of sentence here, is I really think we need to write our answer with the x on the left. And notice how it's like pointing at the 6. I'm going to keep it pointing at the 6. And so really, this is the better answer. I don't like this one as much. This one's better. The reason it's better, because now I go to my positive 6, and I put a solid dot because it's equals, and I go to the right because it's greater than. This way, my arrow still points the same way. This one, it wouldn't point the same way. It might be a little bit confusing. So I'm actually going to put another line in the sentence here. Okay, I added a sentence because I said, or when you have to move the variable to the left if it started on the right. And that's what I did here. All right, let's do another couple of examples. Okay, this one I can already tell that, hang on. I can tell that this one I'm going to have to do that again because my z is on the wrong side. Okay, let me just go through solving it. First of all, I'm going to subtract my 8. That's going to give me a negative 24. Is greater than negative 8z. I need to divide by negative 8. Okay, here's the tricky thing. When I divide by a negative 8, what do I have to do? I have to flip my sign. So over on the right, I have my z. Over on the left, negative 24 divided by negative 8 is a positive 3. So sort of I'm done. And I say sort of because I'm going to say not really. I really like to have the z on the left. So if I was pointing at the 3, it has to stay pointing at the 3. I like this answer better. Now I can go to my 3, make an open dot, and point it to the right. Oh boy, the next one has a fraction. That's okay. We are big people and we can do fractions. So we have n over 6 greater than negative 1. How do I get rid of a fraction? The way you get rid of a fraction is you multiply by the denominator. So if this is a 6, I'm going to multiply times 6. And when I say 6, I really mean 6 over 1. Because now this gives me 6n over 6, and those 6's cancel out, and so I just get an n. And on the right-hand side, I have a negative 6. Okay, there was a lot going on there with fractions, but guess what? I don't have to move my symbol. I don't have to change it because I didn't multiply by anything or divide by anything negative. There was a negative, but I didn't multiply it or divide it, and so it doesn't change anything. Okay, I go to my negative 6, I put a dot, it's open because it's not equals, and is pointing to the right because this arrow is pointing to the right. Last two. Okay, first of all, remember, if they are on the same side of the equal sign, or the inequality, we combine them first. So I'm going to combine these. And when I combine negative 4a plus 6a, I get 2a. Some people get a little bit confused because they're like, why is there a 0? Well, that's okay. Just pretend like it's a number, because 0 is a number. Let's divide by 2 to get that a all by itself. 0 divided by 2, try it on your calculator. What's 0 divided by 2? It's just 0. And then again, I don't have to flip because I divided by a positive, not a negative. That gives me an a over here. Technically, I'm done, but really, I think it's better to switch it. It was pointing at the a. I'm going to keep it pointing at the a. So I go to my 0, make an open dot, points to the left. It's going to go to the left. Last problem, I'm going to distribute this. When I distribute this, 5 times 7 is 35. I have a 5m, and then I have my plus 6. Oops, I don't need an equals. Greater than 61. I need to combine my like terms. I have a 35 and a 6. I need to add those together to make 41. I need to make sure I get my sign pointing the right way. Okay. Just need to solve it like I would solve an equation. Same process. Subtract my 41. That gives me 5m greater than 20. Okay, I need to divide by 5. Is that a negative 5? No, it's not a negative 5. It's just a regular 5. I'm kind of out of space. I'm going to come over here. That's going to give me an m greater than 4, because 20 divided by 4, my calculator, 20 divided by 5, my calculator, is 4. So I go to my graph, I put a dot. Is it pointing the right way? It is. The m is on the left. That's where it's supposed to be. Pointing, does not fill in because there's no equals, points this way. Okay, I kind of feel like I went really fast on those. We will go over those in class, and so we have some practice with them.